Okay, hi everyone. We're going to work on trig ratios today, our specific sine, cosine, tangent. So trigonometry ratios. Sometimes you call it trigonometric ratios. And from Algebra 1, we learned ratios, not rationals, ratios. The idea of ratios are they're fractions, and what they really do is they compare things. Like, what are the ratio of boys to girls? What are the ratios of the rich versus the poor? What are the ratios? So whenever you hear the word ratio, it's just a way of comparing. So the ratios that we're going to talk about are sine, cosine, tangent, secant, cosecant, cotangent. And these are just going to be abbreviated with 3 letters. So we'll talk about this right now. And let's go ahead and draw a right triangle. So our sine, cosine, tangent can only be used to start with our right triangle. I'm going to call angles A, let's call this angle A, B, and so, yeah, let's do that. It doesn't matter. A, B, and C. Okay. And let's label the sides. Actually, you know what? I'm sorry. Can you guys change that? I made a mistake. It's easier if we do it this way. A, B, and then C is the hypotenuse. So it's going to be little c, little a, and little b. Okay, so we want to learn the terminology for what we're going to use. So let's go ahead and start with our first example, and then we'll lay it out. Sine is the ratio. We're going to refer this in a shorthand for SIN. Sine of angle A is equal to opposite over hypotenuse. That is the ratio we're going to refer to. OPP stands for opposite, and hypotenuse is HYP. So what is the opposite? Well, the sine of A means we are going to look at angle A. So let's look at over here, angle A. Now, what is opposite of angle A? Opposite of angle A is going to be this side here. That's opposite of angle A. So that's side A. I'm going to label this as opposite, OPP, opposite. The hypotenuse is always given by opposite of the right angle. And the adjacent is right next to A. So that's going to be ADJ, labeled adjacent. So every triangle that we're going to look at today is going to have these 3 sides. Though the sides might not be in the same places, hypotenuse is always going to be opposite of the right angle, my largest side. Opposite will always be opposite of the angle I am talking about. And adjacent will always be the side next to that angle I'm talking about. In this first example, we said sine A, so that's the angle I'm talking about. What side is opposite of angle A? It's side A. What side is the hypotenuse of the triangle? That is side C. So we're going to label this as equals to A over C in this case. Let's change this and write a different one. I'm going to say, what is the sine of, whoops, not capital, sine of angle B? So now we're standing on the other side of the room. I'm standing over here now. Okay. Now, what side is opposite of angle B? That's going to be the side over here. Isn't that opposite? It's the side that opens up to it. So angle B is in this corner, and the side that opens up to it, it's this guy over here. That's the opposite side. So we're going to still label it right now. It's going to be opposite is OPP over hypotenuse. Sine is always this ratio of opposite over hypotenuse. So let's look at the triangle. The opposite of B, angle B is side B over hypotenuse C. That's the setup. That's how we're going to start. We never say angle C, the right angle, because the opposite and the hypotenuse, wouldn't they be the same thing? So we never talk about the angle of the right angle. It's always the other two acute angles. Okay, let's talk about sine again. Let's give you guys another triangle. I'm gonna spin this around. This is a right angle here. Call this 3, 4, 5. I'll call this angle A here. What is the sine of angle A for this triangle? The sine refers to opposite over hypotenuse. Now, how are you going to remember this? Well, if you guys ever stepped one day in church, they always talk about sin. And do they say, oh, you should cozy up to sin. Sin should be your best friend. No, they always say stay as far away from sin as possible. That's opposite. Stay out as far as possible from sin. But please don't call it sin. It's sine. It's just an abbreviation, right? It's actually sine. We write SIN as an abbreviation. So the opposite of A is 3. That's my OPP. The hypotenuse of the triangle, the right angle, is going to be 4. That's hypotenuse. So we just always write the fraction. These are trigonometric ratios. That means they always have to be a fraction of opposite, which is 3, over hypotenuse, 4. Right now, I want you guys to tell me what is the sine of angle B. I'm going to post up a poll in just a moment. So go ahead and think about it. It's going to take me about 20 seconds to come up with this poll. Oops. One moment. Okay, find me the sine of B. Okay, give you guys 5 more seconds to respond. Okay, the poll results show that most of you guys think that it's going to be 4 over 5. Let's talk about what is the opposite of angle B and what is the hypotenuse of the triangle.
Mr. Ko, I don't think the correct answer was in the multiple choices.
Yeah, that's what I was gonna say.
Oh, whoops.
I just
Okay.
chose the closest one to it.
Darn it. I thought I wrote them all. Okay, whoops, sorry. Okay, so let's go over it real quick. Probably right. Shouldn't do things so quick. So, opposite of B is 5. Oh my gosh, I even have the triangle wrong. Gosh. Okay, this triangle is wrong. The hypotenuse always has to be the biggest side. Oh gosh. Let's just take the numbers as it is. Gosh. It's 5 over hypotenuse is 4. Okay? This triangle doesn't exist. That doesn't exist. Because the hypotenuse is too small. Sorry about that, guys. Try to do things on the fly. Answer wasn't there. That's right. And also, this triangle doesn't exist. So let's do this again. I'll fix it this time. Okay. I'm going to draw it this way. We'll do 10. And then we'll do 6 and 8. Call this A, B, and C. What is the sine of angle A? And then what is the sine of angle B? Okay, come up with those two answers. Trick question. Okay, so tell me what the sine of A and sine of B is. Okay, sine of A, hypotenuse is 10. The opposite of angle A is angle 8. So 8 over 10, we can reduce to 4 over 5. Sine of angle B, the opposite is 6. It's going to be your OPP. And a hypotenuse is 10. That's going to be 3 over 5. Now, one thing we want to be aware of is that our opposites and adjacents can always change depending on where I'm standing. If we were in class right now, if I was standing on one side of the room, the opposite would be different if I stood at a different part of the room. So every angle gives me a different opposite, but the hypotenuse for that same triangle is always constant. Okay? So let's go ahead and come up with the rest of them now that we get the basic idea. So sine, we said sin of, let's say, theta is opposite over hypotenuse. Cosine, if you look at the word co here, Mr. Co is like your buddy. Cosine is just COS, and that's adjacent over hypotenuse. Tangent is abbreviated TAN, and that's opposite over adjacent. How do you know this? Well, I taught you sine first, and if sine is opposite, and then I taught you cosine next, so it's opposite over adjacent. Always opposite over adjacent. We can do our additionals, our flip version. We can sometimes call this reciprocal. Reciprocal identities, and this is going to be cosecant. Darn it. Oops, let me write it again. Cosecant, and that's CSC. Cosecant. Don't say cosecant, just say cosecant is hypotenuse over opposite. Now, if you want to look, this is very similar to sine. It's just the reciprocal of it. Instead of opposite on top, we have the hypotenuse on top. Secant is SEC, and that's going to be hypotenuse over adjacent. Hypotenuse over adjacent. And cotangent is going to be COT, which is just like what we've been doing. We've just been taking the reciprocal, the flip version. It's going to be adjacent over opposite. Adjacent over opposite. Now we've taken all the possible combinations we can. We've mixed every side with every corner of the triangle. So we have a name for every one of these sides, or these ratios, these comparisons, you could say. Okay, let's give you guys a problem here. What is the tangent of a triangle theta is equal to what for this triangle? Let me draw the triangle. Theta, and we'll say 7 and 10. So looking at theta, tangent is opposite over adjacent. It's opposite over adjacent. So looking at the triangle here, the opposite side of theta would be 7. And the adjacent, which is right next to, is going to be 10. 7 over 10. So to bring this around, if I know tangent, you also know cotangent, because cotangent is just the reciprocal of this. So if I ask you what's the cotangent of the same theta, well, that's the reciprocal, adjacent over opposite. That's just 10 over 7. How could I find the third side in this triangle. Given two sides of a triangle, I could find a third side using Pythagorean theorem. So to use Pythagorean theorem here is, we say a squared plus b squared equals to c squared, Pythag. To use Pythagorean theorem, we have to say, okay, I know 10 is a leg, 7 is a leg, so I'm missing the hypotenuse. So we're going to say 7 squared plus, oops, let's use the other way. It doesn't matter the order for the legs, but I wrote a there, 10 squared plus 7 squared is equal to 49, c squared. 10 squared is 100 plus 49 is equal to c squared. That's 100 and 49 is equal to c squared. We take the square root of both sides. C is equal to the square root of 149. Now, I can't think of any numbers I can divide 149 by. I think it seems like it probably is a prime number for us. So the square root is 149. That is the value of C. So sometimes we have to use our theorems to find that missing side. And in this case, that's what we're going to do, find that missing side. Now, since we know the hypotenuse now is square root of 149, what is the sine of theta? Sine is opposite over hypotenuse. That means the opposite is 7 over the square root of 149. Now in the IXL, they're going to ask you to write this in the simplest form. And the problem is, one of the rules that we have from Algebra 1 is you are not allowed to leave a square root in the denominator. So since we cannot leave a square root on the denominator, this was a rule from Algebra 1. You multiply the denominator and the numerator by that same square root. When I multiply something by that same square root, this square root goes away, and it simplifies to 7 square root of 149 on top over 149. And in this case, I cannot divide the 7 from 149, so we are done. What is the cosine of theta in this case? Cosine stands for, let's look back at the top. Cosine is adjacent. Remember, cosine is your co-buddy. Think about co-pilots, co-worker, and don't they work adjacent to you? So that's our adjacent value. So cosine is adjacent over hypotenuse. Looking at the triangle, the adjacent value right next to theta is going to be 10. Hypotenuse is going to be the square root of 149. Follow-up question, am I allowed to have square roots on the denominator? Are we allowed to walk around with our pants down? No. My daughter is in first grade, and the Zoom teacher yesterday had a parent meeting for all the parents, and they asked us not to have the camera pointed to the background where people could be walking around, because she said one of the kids' parents walked around without his shirt on. And maybe that's okay in their family, but I don't think the other kids in first grade want to see your dad without a shirt walking around the house. So please fix the square roots. I'm going to pause here for a moment. As some of you guys mentioned in class, a way for you guys to remember the trigonometric ratios is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA is opposite over adjacent. SOHCAHTOA. SOHCAHTOA was the name of it was Pocahontas' little sister. I don't know. Oh, it sounds so funny. SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You can just write that on top of your test one day. Now, we want to look at the reciprocals though. So let's look at what is cosecant theta. One cool thing is that we already wrote what it is here and here. But if I want to go back, it's hypotenuse over opposite. So hypotenuse is square root of 149. And the opposite of angle theta, opposite, is going to be 7. Secant theta is hypotenuse over adjacent. And that's going to be hypotenuse 149 over 10, adjacent. And then cotangent of theta is adjacent over opposite. And the adjacent to theta is 10, and the opposite is 7. Okay, you guys will be doing this in IXL today. You guys will be asked to do this to 100. Now, let me give you guys some funny ones. So, what if I give you a sine of theta is, let's say, square root of 32 over the square root of 25. Let's just give a random example with square roots here. So we can either mix the square roots or simplify them separately. Both of them are okay. We can mix them or simplify. Mixing means I can write them as one big square root. Or we can separate them as they are. The square root of 25, we know is 5. Now, to do the square root of 32, we talked about this before in our last lesson. The square root of 32 can be written using what I call a box method. What's the smallest number I can divide 32 by? 2. 2 goes into 32 16 times. If you can't do that in your head, divide slowly. 2 goes into 3 one time, remainder 1. So I write the 1 here. 2 goes into 12 6 times. Done. 2 goes into 16 8 times. This is actually an upside down division, folks. That says upside down division. 2 goes into 8 4 times. 2 goes into 4 2 times. And for square roots, we circle our pairs. 1 pair, 2 pairs. So we have 2 times 2 is 4, left over 2. That's 2 times 2 left over 2. That's how we end up with the 4. Let's do another one. That's a little funny. Sine of theta, let's say it's 4 square root of 12 over 3 square root of 24. So if you see you can divide stuff, maybe, but instead, I'm just going to take the square root of them separately. 4, if you guys want to do this in your head, what square root do you see in the number 12? 12 is 4 times 3. The square root of 4 is 2, but I can't take a square root of 3. On the bottom, 4 is in 24, right? So the square root of 4 is 2 left over 6. We can reduce this 8 square root of 3 over 6 square root of 6. That still doesn't work for me. And now there's a couple ways of doing this. We can either divide it or we can just move the square root to the top. And if I multiply both sides by square root of 6, this becomes 8 square root of 18 over 6 times 6, because square root of 6 times square root of 6 is just 6. We can rewrite this as 8 over 36, square root of 18. But man, can I take a square root of 18? Well, if you can see, isn't this 9 times 2? So square root of 9 is 3. 8 times 3 square root of 2 over 36. 24 square root of 2 over 36. We can still simplify here. 24 and 36 reduce by 12 to become, right, they reduce by 12. Divide by 12. That becomes 2 square root of 2 over 3. Now that looks like a lot of work, right? So there's a lot of different ways of reducing these fractions with square roots, and it's up to you, since there's so many different ways. So another way we could do this is by just reducing the radicals. 4 over 3, oops, 4 over 3, and we can write this as one big square root of 12 over 24. This reduces to become 4 over 3, 1, oops, don't need the 1 anymore, but really over square root of 2. Do we like the square root of 2 on the bottom? Nope. So we can multiply the square root of 2 on the bottom and the top. 4 square root of 2 over 3 times 2, because the square roots cancel out. And we can reduce the 4 and the 2. 2 square root of 2 over 3. So there's a lot of different ways you could go about reducing this fraction with a square root in it, but we just have to practice the different methods. And if you need help with that, you guys can ask. If you guys need some IXL practice on how to do this, let me know. But it's always simplifying after we try to get rid of that square root. You could simplify first. You can simplify first. You could have multiplied. Here's another one. 4 square root of 12 over 3 square root of 24. You could multiply both sides by square root of 24. That is 100% okay. 4 square root of 12 times 24. I'm going to give you a trick there, okay? And it's going to be 3 times 24. Well, square roots take out pairs, don't they? Now, doesn't the 24 become 12 times 2 really? And then you have a pair of 12s. This can be rewritten as 4 times 12 square root of 2 over 3 times 24. And the reason why I didn't multiply that 24 is because, look, doesn't 12 and 24 reduce? Yeah, it does. 12 and 24 reduce to become 2. And then doesn't the 4 and the 2 reduce to become a 2? And we're left with 2 square root of 2 over 3. Same answer. Okay. We've got one more last thing that we want to work on from geometry. And that is how to solve a missing side using our sine, cosine, tangent. Let's see, how long have we been? No, I think we are out of time for today. So let's work on this, and we'll work on the next one later. So let me change your assignment.